Good morning, my faithful geometry class. Thanks for checking in this morning and watching this video. I wanted to apologize for all of the technical difficulties and me figuring things out last week for the quiz, but I did compensate by adding 10 points to everyone's quiz, so I think that that's fair. And I did receive almost everyone's. I have one more I'm waiting on. So after that, there's one question in particular that I'll make sure that I go over with you so that you can understand. Thank you for your patience. Thank you for your diligence. And I would just encourage you to please make sure that you watch all the videos from beginning to end to make sure there's other videos also that your textbook publisher has released, so hopefully you can look at those if you need additional help in addition to the things that I'm saying to you for these. So let's get right on with it and take a look at inscribed angles. I do miss you very, very much, and I just hope that we'll be able to see each other face to face fairly soon. I'm working on some things, learning a few things, and I'm looking forward to doing that at some point. All right, so let's take a look at inscribed angles. You know, as you're taking notes, you're writing the things that you need to in your notebooks, and I do encourage you to keep doing that, even though I'm not giving you the blank pages. You can pause as much as you want, write down the things that you think that you need as far as doing that. If you have access to a printer, I know not everybody does, but you can always change your settings on your PDF printing to print multiple pages per page. That way you won't be using up all of your ink. You know, 1 page per slide would get to be quite a lot. But if you just skim those down and choose the pages you want to print, that should be helpful to you. And I think most of the printers have settings like that. All right, so anyway, on to inscribed angles. We've used that word inscribed before, but we need to specify it for angles. In order for an angle to be inscribed, the angle has to start and end right on the circle, and the vertex has to be somewhere else on the circle. So for example, this angle right here, angle CMK, is inscribed because it starts and ends on the circle, and the other point, the vertex, is actually on the circle. Angle BAN is not what we call an inscribed angle because even though it starts and ends on the circle, A doesn't go all the way across. It doesn't hit a point also on the circle. So that should clear up as far as what an inscribed angle would be. So in this particular circle that we have to take a look at, there's one inscribed angle, angle ADB, and there's another angle, angle ACB, which is not inscribed. However, I hope that you are remembering that angle ACB is actually what we call a central angle. Central angles are important, so we'll just throw that word back out there for you. The reason central angles are important is, remember, a central angle is the same number of degrees as the arc that it intercepts. So AB has a measurement then of 70 degrees simply by the definition of how many degrees are in an arc. Okay. The other question is asking you how many degrees are in angle ADB, and we need this theorem right here for that, is that the measure of the inscribed angle is half the measure of its intercepted arc. So the only thing you have to do to find out how many degrees are in an inscribed angle is to divide this number by 2. 70 divided by 2 is 135. I mean, not 135, 35 degrees. So 35 degrees is the number of degrees in this inscribed angle. So measure of angle ADB is 35 degrees. And so you're going to be doing quite a few problems, and we'll be talking about quite a few things relating to this idea of the inscribed angle being half of the intercepted arc. All right, so we have this diagram. It's got quite a few inscribed angles that are hiding in it. Okay, and we're going to use what we know about them in order to find other angles. We're also given that angle ABD is 50 degrees, and we'll hold on to that information for a little while. But we're also given that the measure of arc ED is 30 degrees. If you see a degree measure on the outside here along the circle, that's telling you that this is how big this arc is. So our first question is asking us, if we know that this arc is 30 degrees, then angle DBE, based on our other theorem, would be that divided by 2, which is 15 degrees. Okay, so this is your angle, and this is your arc. The inscribed angle is half of the arc, 15 degrees. Angle ABE, we can think about that one, but we need to understand and remember that angle ABD is 50. So if 50 is this one, and you put 15 with something to give you 50, it should jump in your head, you're subtracting. So you're taking 50, oops, there's your inscribed, sorry about that. 50 minus 15 will give you 35. There will be your angle, because 35 plus 15 give you 50. So 50 degrees for that, for the whole thing, 35 degrees for angle ABE. Then we can think about arc AE. Arc AE, remember the inscribed angle is half of the intercepted arc. So we're given the half part. So in order to find out what the arc is, you have to multiply by 2. So a lot of the work on these particular items are going to be either multiplying by 2 or dividing by 2. If you're given the arc, you divide by 2 to get the angle, but if you're given the angle, you multiply by 2 to get the arc, because the angle is half of the intercepted arc, as long as the angle is inscribed. All right? Good. Now, as always, you should try to anticipate these things before the answer is revealed. You can pause as many times as you need to so that you have time to think. All right? So here's another question to ask with this same picture. What other angle is 15 degrees? Well, it says has is. That's not very good. But what other angle is 15 degrees? So when we're looking at that, if we have this angle being 15 degrees, we have to remember that every arc has probably millions and millions of inscribed angles that intercept it. So all of those that intercept this arc are also going to have to be 15 degrees. So here is another inscribed angle that also intercepts this arc ED. So it would also have to have 15 degrees. So angle DCE also has a degree measure of 15. Angle ECD is another way of saying DCE. Remember, we don't care about which letters come first and last. You could put the D first, then the E, or the E and the D, but the C is the vertex. That just goes back to our angle measuring conventions we talked about earlier in the year. Okay? All right, moving right along. We have another theorem. If you have a circle, or you have a couple of congruent circles, this goes along with that little thing I was just pointing out. Angles that are inscribed will have to be equal as long as they are intercepting the same arc. So you could draw millions and millions in here. If I went across here, I'm going to get another angle that's congruent. If I go across here, I'm going to get another angle that's congruent. You could do that all day long and get congruent angle after congruent angle after congruent angle. All of these angles that are drawn in here, they all intercept RT. So they're all taking half of the same number, so they all have to be the same number of degrees. They are all congruent. So all of these angles have to be congruent. That is also the case where you have a semicircle. Semicircle, remember, is made when you go through the center of the circle. So an angle inscribed in a semicircle would have to be always being half of 180 degrees, which would mean that every time you draw an inscribed angle that starts and ends on the edges of the semicircle or on the edges of the diameter, you would have to get 90-degree angles over and over and over again. If you have a true circle, a really quick way of drawing right angles is just start on a diameter, bounce down to the circle, and end on the diameter. So the heart of this theorem is that these have to all be right angles. They're all half of 180, so that should hopefully make a lot of good sense to you. Now here's an interesting theorem. If you have an inscribed quadrilateral, remember quadrilateral is a four-sided figure, so an inscribed quadrilateral would have there'd be basically, in order to draw one, if you sketch out a circle, all you'd have to do is put 4 dots on there and connect them all. And you've got your inscribed quadrilateral. What it tells you is that the opposite angles have to be supplementary. Remember, supplementary means they have to add up to 180 degrees. So this one plus this one has to be 180. This one plus this one has to be 180. And what we're going to do is we're going to talk about why that makes sense. Okay? You're going to need to be able to know that as a fact for your assignment, that A plus C equals 180 and B plus D equals 180. But as I said, we're just going to take a little sideline here to explain why it makes sense. And remember, explaining why it makes sense is just a simplified way of saying we're going to prove it. If you don't like that prove word, we're not doing a formal proof, but just walking through why it makes sense. So even if you don't write down this proof, I want you to at least listen through and maybe replay it so that it makes sense to you. Okay, so first of all, I'm going to take a look at this idea. We're going to show you why x plus y has to equal 180 degrees. So I'm just going to label this one as angle x and this one as angle y. So that means because our inscribed angle is half of the intercepted arc, that means that arc ADC is going to be 2 times x, and arc AC is going to be 2 times y, because this one is half as big as the intercepted arc. And here's my reason, because for an inscribed angle, it's half of the intercepted arc. So what that means is that this arc plus this arc, arc AC plus arc ADC, has to equal 360 degrees, because that's how many degrees make up a complete circle. Okay, remember, do a 360 means turn all the way around. That's a complete circle. I'm going to do a little bit of algebra here. I can factor out this 2, kind of like undistributing it. So 2 times y plus x is going to equal 360 degrees. Technically, if I needed to give this a property, I'd say it was the distributive property. If I then divide both sides by 2, I end up with x plus y equals 180. And remember, x plus y equals 180. When you have 2 angles that add up to 180, that just means that they're supplementary, because it's the definition of supplementary. So right here, I've just proved that no matter what the opposite angles are, I used variables, so that means that everything that I did here is all just math legal. And I've just shown you why these 2 angles have to be supplementary. Now, once again, you're not necessarily going to have to run through this proof, but using it as a fact is going to be important for you. So let's take a look and let's work our way through this scenario in order to find all of these missing pieces. What we have is we have circle A, which means that A is the center. It means that this does have to be a diameter. We're given that arc CKD is 250 degrees, and that is going to end up being important by the end. And so let's make our way through this problem. What you should probably do is pause for a second and maybe sketch it out, or print it out if you have access to a printer with the blank one, so that we can work our way through. Okay, so the first thing that we can look at is the angle KDE. Because this is a semicircle, this is 180 degrees. Half of that is 90. Okay, so 90 degrees is our first answer. Oops. All right, so that might be helpful down the road here. Arc DE, well, we know that this is 58 degrees. We know that it's a right triangle. So what that tells us is that between this angle, angle DEK, and angle DKE is going to have to make 180 altogether, but these 2 together have to make 90. So you can just take 90 minus 58 to find out that this angle here is 32. But wait, that wasn't asked. Well, it is important though, because remember, the inscribed angle goes with the intercepted arc. We're asked here for the intercepted arc. So if I find this angle, I can find the intercepted arc. And from what we were saying, think for a minute, what do you need to do? You need to multiply that by 2. So that would make this number of degrees 64. Even if it doesn't look like it, it is not drawn to scale, not meant to be. But if I have this angle is 32, this angle comes out to be 64 degrees. Or not angle, the arc comes out to be 64 degrees. The angle that it goes with would be angle DAE, if we're thinking about that with inscribed angles versus central angles. Arc KD, okay, let's think about arc KD for a minute. Arc KD goes with arc DE to make half a circle, or a semicircle, and think about how many degrees that is. If a full circle is 360, that means half a circle is 180. So one way we could do that would be taking 180 minus 64. But another way of thinking about that would be if you took 2 times 58, because we also have an inscribed angle here. And that gives you 116 degrees. It gives you 116 degrees by taking 2 times 58. It also gives you 116 degrees by thinking about the half circle. 180 minus 64 would also give you that same 116 degrees. So 116 degrees is your arc KD. Either way you choose to look at it. Now, thinking that through, we have to now bring in, we're trying to find KC. Okay, so in trying to find KC, KC plus KD would have to give you CKD, which would be that 250 degrees. So in order to find arc KC, what you would need to do is you need to subtract 116 from your 250, and that'll give you 134 degrees. So your arc KC would have to be 134 degrees. Once again, this picture is not drawn to scale, but if it were to scale, then you would be able to find, then all these numbers would be 100% accurate. What we can tell from this picture is that we can definitely use this idea of a semicircle, because we've defined this as the center, or 180 degrees, and you can use your arc addition postulate like we needed to do to find out your arc KC. And that about closes it out for the day. Please make sure that you do your next assignment and that you're entering these things daily. There is going to be a link posted tomorrow for you to put in assignment 48. Have a pattern where you're ready at the beginning of your class time to turn in your assignment. So it's not like when it says turn it in by 3 o'clock, it's not like, or whatever time that I choose for each day to turn it in. It's not like you're supposed to be doing it that day. It's like you were supposed to be doing it the night before, just like your other assignments, so that you would be ready at class time to turn them in. We're just turning them in a different type of a way. Please, be on your toes as far as what the expectation is. Always do your assignments honestly. You are certainly welcome and encouraged to check with each other on homework assignments, but quizzes and tests, please take them independently of each other. Don't ask people for help on them unless I specifically give you directions to ask for help. But your quizzes need to be done in all honesty and by yourself. So we're just going to make sure that we're all using a lot of integrity, and so that will be the best thing for your learning. All right? All right. God bless you all, and I look forward to seeing you when I get a chance to. And don't forget to send your prayer requests if you need them. I am still making those prayer videos every morning, so I do encourage you to watch them. Okay, love you all, and God bless.